Good morning, everyone. Hello. Welcome to my session. My name is Soumaya Eddahech. I'm part of the sales engineering team of OpenEdge, and we'll be glad today to present the DevOps framework, which is a new topic since maybe version 12 of OpenEdge. So it's a new topic. Let's maybe discover it today together. It's the early morning, so I can understand that some of you are still sleepy, but please raise your questions through the session. Stop me. Don't maybe keep your question till the end, but stop me. Let's do it in an interactive way. Okay. This is not working. Not an issue. Okay. Yeah. So all of us remember the biggest outage in the IT history, what happened in the 19th of July. And what happened to all the Microsoft system, where we had an outage of maybe more than 8.5 million of machines. They were not working. They had this blue dead screen. And yeah, maybe we might ask ourselves how this might be linked to the topic of today. But I will raise this question: how could we maybe avoid such issue? Anyone knows? Sorry? Better testing, yes, right. Better testing was key because the patch was delivered before even maybe being 100% sure that it was tested. But why maybe we didn't do the right testing? I think also an issue of this was the fact that some of the servers in the Microsoft 365 were also stopped. And we know that servers in the cloud are always replicated, but these servers was replicated with this issue. So also the DR machine was also having this patch installed into it. So maybe replication also on real time wasn't the best approach here. But here we can understand that we had automations, but maybe not enough automations in our way of delivery, maybe not the best CI/CD pipeline to set up. So it's kind of linked to our topic today. If we have automations and CI/CD and DevOps, it's good, but sometimes we don't make the right steps, and then we end up with big issues. Our agenda for today is, first of all, to understand maybe what is DevOps and CI/CD, then see a bit of the DevOps framework of OpenEdge, then see how this DevOps framework is built on what this DevOps framework is built, and then have a bit of a demo. So, yeah, what is DevOps in general? DevOps is a methodology that helps people to put the developer team and the operational team to work together. In the very first stage of IT development, we had developers developing in waterfall or Scrum methodology, doing their work alone, and then the time of the release came, and then they will be sending this to test, and then staging, and then production, but the teams were not working together. And we find out that there is a bit of a gap between what the developers are doing, operational people are suffering from. And then the need of having these two teams working together came into, we noticed this need. So DevOps implemented automation, iteration, monitoring, but the main thing of why we invented DevOps was the need of having the two teams collaborating together. So have the team of operational people and developers working together to fix issues. And then with this fast feedback from operational people, saying, for example, the patch was not working, the testing was not successful, and so on. We could solve issues quickly. We could be more familiar with the delivery process. It's not that stressful process that we are dealing with today, and yeah, makes the process way smoother. Nowadays, we talk not only about DevOps, but we talk about DevSecOps. DevSecOps is also the introduction of the security team into this game. So security is key nowadays. And now we are more in a field of designing applications that are security first. So to do this, we need to have our security team involved in the very first step of developing our project and also in delivering it and testing it. So having the three teams working together will maybe we will call it as a methodology the DevSecOps, and will give us better results because we will be able to do our testing properly from security perspective. We will be having our development team working together with the operational and security people to deliver the results we want to have. And at the end, it will also improve our user experience. So what are maybe the benefits of DevOps in general? It's from different angles we can see that this methodology or this approach has different benefits. But mainly, if we think of maybe developers, it will help them automate some of the tasks they are dealing with. For maybe test engineering, they will have this possibility to collaborate with developers. They have possibility to faster resolve their issues. Also post-production, post-delivery, we will have at the end a good end user experience. People, if we are delivering smoother, if we have these ways to automate our delivery, we could deliver without even our end user noticing that we are delivering. If we are talking about big providers today, for example, Netflix, they are delivering more than maybe 100 times a day. And they have like this methodology, you build it, you run it. So if you build that microservice, you are the person who is responsible to test it and deliver it and have it in prod. So they were the first ones who adopted DevOps, and nowadays you can maybe watch your film, and in the background they are delivering some features to you, and you are not even noticing this, and this is magic. Also from customer service point of view, if we are delivering with an automated way, we are testing automatically our code source. We are sure that all our dependencies are solved, our sites and installation are standard. Then also from a customer service point of view, this will be also improved, because at the end, customer service won't be receiving these lots of calls, bugs, problems to be resolved. Whenever we start a DevOps journey, it's always like a bit of maybe a problem for the development team and operational team to start learning this methodology and know how to use it for work. And there is for sure some challenges, but there is also some grades or some phases in the maturity of implementing it. So you might, for example, start at least having a definition of how this will be working in your organization. Know exactly what needs to be done and who needs to be doing it and when, every time you are delivering a new release. So at least you have in your organization something set, like internal rules of responsibilities through your team members. Also, you need to, before going to the automated phase, you need to define your measures and know all of these steps that needs to be maybe automated afterwards in your process. Maybe the mature phase of this DevOps cycle is the optimized DevOps cycle, where you will having this CI/CD pipeline working, and you will be in a measure of always reviewing it, optimizing it, and seeing what can be done in a better way. So in general, with CI/CD pipelines, the first thing starts when our developer submits his code source to his Git repository or his source versioning tool. And from that moment, we will have our code source that needs to be converted to something that we can execute in other servers and other machines. And then we will, at that point, we will start the continuous integration, which mainly is the part of automating the build and automating the build and having resolving all of your dependencies, all the components needed to for your software to be working. Also perform your automated tests. Once we have this automated tests performed, and maybe we do some security code assessment, then we pass to we move from the CI part to the CD part. So we here are in the phase of delivery. So we will be moving code artifacts to the repositories we want to have. For example, you have development server. After you perform the build, your tests were successful or is fine, you will be moving that build into your testing environment. And then in your testing environment, you will be maybe performing some other type of testing, like, for example, performance testing. You will do load testing to check the performance of your software under load. And then you maybe also perform some functional testing. Then once this is done, then it will be ready for a phase of release if you want to maybe to put it in a staging environment or put it in a production environment. So this is a cycle that has different phases, different steps, and it's a non-ending iteration. If we adopt CI/CD and DevOps as a methodology to work with, then we will be more comfortable to the change. We will accept releasing, and we will not have that stress of, hey, I have a new patch of OpenEdge, or I have a new patch or a hot fix of my application, and I need to install it. And sometimes we have different sites for our end users, and sites are not standard. Maybe developers are changing some settings directly on customer sites, which is not recommended at all. But we have in real life, we have these scenarios, and this makes us always not comfortable with the change, not willing to do it, not willing to maybe. For us, it's not the bad. We know that once we do it, we will end up with a lot of bugs, a lot of calls, a lot of fixes, a lot of troubleshooting. And just to avoid all of these, if we adopt a CI/CD methodology and we automate some of these phases, then not only we are winning time and avoiding a lot of errors since it's automated, but also we are getting more familiar to this let's say Netflix way of working. Okay, so this is CI/CD, but where is the DevOps framework? Yeah, so the DevOps framework is mainly a framework that focuses on the build phase. So we delivered a framework that help you automate the build phase. So if we talk about, for example, the word CI/CD, then we are more in the CI part, the continuous integration part. And yeah, we have a tool that will help you to take your code source and convert it to something that is able to run on machines, on other servers. And you might say we could for sure compile code source without the need of this CI/CD pipeline. But the building process is more than a compilation only. So if we maybe see the steps of building an ABL project, so we have many steps before maybe having or besides the compilation step. So first thing is the management of dependencies. And the management of dependencies is not only like solving the ProPath and knowing all libraries included in our application or that our application is relying on, but also managing dependencies when it comes to database connectivity, creation of database, the deployment of a new database scheme. All of this is part of the dependencies before the compilation part. Then we will have the compilation part. We have also the execution of unit testing. I don't know if you are familiar with unit testing. Who has a bit of experience with the ABL unit testing? Okay, very good. Yeah, good numbers. Yeah, so ABL unit test is a framework which is not new. It's maybe since the version 11.5 of OpenEdge. And it's a framework that helps, it's a framework that will help you automate your testing. And it was designed with the fact that you will write classes where you define your test cases and you define also the expected output, input for these different testing scenario. And then the test will be executed with the output, an output result file that gives you the result where whether your tests were successful or not. And unit testing may be very important part in the life cycle of our development. If we have this big application with a lot of features, we will need to make sure that the smallest features are working properly, and this can be guaranteed using the automated unit testing. Another thing is maybe the execution of static code analytics, which is not for today not supported with the DevOps framework, but also the generation of API documentation and also the generation of the package that you are finally publishing in your production, staging, and testing environment. So the output of that developer, once it's built, once it's we executed the test successfully, then we will be preparing a package, maybe a PASWE package or a ABL procedure library package. So depends on our need. Yeah, sorry.
About packaging, does it include a web client application package?
Yes. So we added this lately in the latest version of the OEDF. It's added. So his question was, does it include web packages? And that we will see it. We will see it through the slides now. Okay. So yeah. So this is nice. So in general, DevOps framework was mainly for repository integration, compilation, testing, and packaging. And if we compare it to maybe some of you are building nowadays using maybe Ant. So they have tools such Ant to automate their builds. Ant is good, but it's not, for example, packaging. It's not. It doesn't have yet the capabilities of maybe connecting to databases or deploying new scheme of databases or creating databases. So it's a bit limited compared with what the DevOps framework can offer to you today. So the DevOps framework is mainly 2 plugins. And we will see this notion of plugins in a minute. But what Progress did is we developed 2 plugins for Gradle. And these two plugins are the ABL-based plugin and the ABL plugin. The ABL-based plugin is the plugin that has into it different predefined tasks that you can run to perform tasks such as compiling, connecting to a database, creating database, and so on. The ABL plugin is also has all capabilities of the ABL-based plugin, but with extra capabilities which are designed for Progress Developer Studio projects. So it recognizes the Progress Developer Studio project and has into it some special configuration for that type of projects. In general, DevOps framework wasn't something which is really new. Like it was released since 2020, the first version of it, and through the versions we tried to improve it and enhance it with features. And we added lately the capability of deploying packages for PaaS, which are maybe web services and OER packages and so on. So we support that from the version 2 of the 2.2 from the OEDF. So OEDF, when it was released, it was working based on Gradle version 5. Nowadays, it supports Gradle version 8. So if you install it, for example, with the OpenEdge 12.8, then it will use the latest, the Gradle version 8.2. Questions so far? Okay. Yeah. Sorry. Say, anyone is using OEDF Gradle? Yeah, I'm trying hard, Ori. I presented several times. I'm trying. Yeah, I think once you know it, once you understand it more, you will be getting more familiar with it and adopt it. The thing. Yeah, so I think it's a matter of like taking maybe the first steps. Once you build the first build script through Gradle, and then you will maybe understand what are the benefits that it presents comparing to what Ant is doing right now. And yeah, I think it will be the future in our way of automating builds. So yeah, it's been around since a bit, so it's time maybe to start experimenting it. Okay. Yeah, so we were talking about Gradle, but what is Gradle? Yeah, so Gradle is an open source build automation tool. And it's a bit of a smart building tool with the possibility of having of a caching mechanism. So we build several times. With the usage of Gradle, you will be able to, at the very first time you build, it will take a bit of time because it's the first build you are doing. But the second time you are building, it will consider changes only. So it will be faster and more performant. Why compared to, more performant way than maybe Marvin. And this is why we choose to work with Gradle. It's mainly because its performance is lightweight when it comes to rebuilding and having this different iterations of build and only consider changes. Also, it's it has a domain-specific language base, so whenever you build with Gradle, you will build your script not using XML, but with specific programming languages, for example, such as Groovy, and this gives it more capabilities in writing your script of build. And also, it gives you also more capabilities, maybe if you want to build your own custom plugin for Gradle. This is also possible. So let's maybe go through some key concepts of Gradle. We were mentioning plugins. And from the very first beginning, we said OEDF is only 2 plugins for Gradle. But what are plugins? Plugins are an association of different tasks, predefined tasks that we think that this work is a bit repetitive. Then let's define them in something like a plugin or kind of a library that everyone can refer to. So you can build your own Gradle plugin. You will be able to use the ABL-based plugin from the OEDF framework that has into it different predefined tasks that helps you in building your projects. Also, what is also important is the build script. So if we talk about build script, so it's the script which is written, for example, in Groovy, and it lives on top of your project, and it has a specific structure of maybe a bit of definition, and then the different tasks that you are running, and the different dependencies that you are resolving, and so on. So this is the script that maybe if you are taking this in the next step and running this through a CI server in an automated way, then this script here will be the script you deliver to, for example, Jenkins or GitHub Actions to just run it automatically. The other important unit is tasks. So tasks are specific different steps that we are doing, or unit of work that we are performing, can be invoked using the Gradle wrapper. With Gradle, there is some basic tasks that come with the plugin, so come with the base plugin of Gradle, such as, for example, build or check, assemble, and there is also you will be also calling some tasks that are predefined in the DevOps framework, such as, for example, the ABL compile and so on. So in your Gradle script, you can refer to different plugins, and you can once you include these plugins in your Gradle script, you will be able to call all the tasks in that plugin. Also, what is important here is that tasks can have dependencies. For example, I cannot compile my code unless I'm connected to the database. So maybe I will need to perform the DB connection task before going to the ABL to the ABL compile tasks, and then also maybe afterwards the build task. Another concept is the wrapper. So the wrapper is a script that will be wrapping all your Gradle dependencies. The script to invoke and run Gradle tasks. It can be also committed to your versioning control. So at the moment you commit the Gradle wrapper into your versioning control, you don't need really to have Gradle installed into the machine where you are, for example, doing testing or staging, because Gradle wrapper will be wrapping everything linked to Gradle, and then it will work properly in your testing environment and staging environment without the need to install Gradle again in these environments. There is also some important files that Gradle relies on, such as the properties and the settings file, where we can define some properties, such as, for example, the name of the project we are working on. Sometimes on developer machine, it's a bit different from the staging or the testing machine. So we will maybe need to explicitly identify the name of that repository. Yeah, so these were the concept of Gradle in general. Here are mainly the tasks that we find in the OpenEdge ABL based plugin. So these are the tasks that we can rely on and can call if we included the OpenEdge ABL based plugin in our build script. Also, here just to say again that we have mainly two plugins, the base plugin and also the OpenEdge ABL, which is mainly designed for Progress Developer Studio projects. And it has into it all the predefined tasks of the Gradle base, plus the possibility to recognize the structure of Developer Studio projects. So in terms of packaging, what are the packaging options? As I said, lately we have introduced,
Excuse me. For Developer Studio, does it include the option to pre-build OpenEdge tooling?
OpenEdge tooling?
Yes, because if you start Eclipse, OpenEdge tooling takes ages. So every developer has to wait for that. Can you build that up front using OEDF so that developers can get started right away?
But if here we are talking about a script that you are running whenever your Developer Studio is already working, so it's up.
You start from Git.
So I think that's a great idea, but in Developer Studio, tooling is specific to the development environment.
So it doesn't help for Developer Studio.
It does help in building. So the base plugin, you can think of it as like having these ingredients, which you can customize and create your own build script.
But the default plugin, the idea behind it was that a lot of customers used to write a different script when they take the project into the staging environment. And so however they used to build in PDSOE, it wasn't extendable to the staging environment. And so once you add this, this file basically has everything that is required to build the project and take the PDSOE project out of PDSOE, and you can use it in the staging environment. It does not build tooling.
Because we are trying to do as much the same during development as during building.
Right.
Even the build for the developer has to be as close as possible to the build that's done afterwards. So, but it doesn't seem to help there.
I think beside tooling, and probably one of the reasons you might be asking it is, are you on 12.8? Are you specifically talking about 12.8, tooling in 12.8?
Tooling, because in 12.8 it's no longer.
Yeah, it takes a long time, and yeah, that's.
I can't wait for it to finish.
Yeah.
Yeah,
I understand.
Takes too long.
But the scope of OEDF wasn't to. It doesn't help in the tooling. You can take your same project and build it in this, like take it to the staging environment, but not tooling.
Okay, thank you. Yeah, so what we were saying, I just forgot. Okay, yeah, so we have we have different packages that we support nowadays. You can have, for example, REST services definition, also delivered through this OEDF plugin or OEDF framework, and also you can have also data object service catalog. Also, it's supported. Then maybe let's go to a bit of real world. So whenever we talk about CI/CD, it's always a lot of tooling, a lot of possibilities. Everyone sees it from his perspective. And we don't recommend a tool better than the other. We don't say, for example, GitHub is better than GitLab or other versioning tools, or this special editor is better than the other. Or, for example, for load testing, you might go with the Test Studio of Telerik. You might go with JMeter if you have a web app to deal with. So there is a lot of possibilities when it comes to automating different phases of our project. There is also some tools that helps with security and code validation, such as SIGRID, which is a tool that will help you to identify if your code, the quality of your code source is good enough in terms of security, in terms of how the code source is written itself, depending or comparing it to the standard of the market. And it supports ABL as programming language. If you are interested in such topic, go to Ronald. I think he's presenting this topic just at this moment. So if you are interested, go to him and talk to him about it. But yeah, again, there is a lot of tooling that help in different phases of the project. And we don't say that we better work with this tool than the other. I would highly recommend that whenever you start this journey on maybe choosing tools, choose tools that has future, that will help you in the automation process, that and also think of what your developers know. So if you reduce the learning curve that is needed to just start this CI/CD journey, this will also help a lot. So if we maybe think of tooling for repository integration and code source versioning, there is different tools. You might go with GitHub or Subversion or whatever tool you want. Also for non-functional testing and load testing, you can go with, functional and non-functional testing and unit testing, you can go with OpenEdge ABL unit testing framework. Also, Postman can be a good tool when it comes to testing your APIs. JMeter, also Test Studio can be a very good tool when it comes to doing performance testing even for GUI applications. So it's able to automate ABL GUI application and perform load testing on these applications. Some people might also go with RPA tools such as UiPath. So if you build a software, an automation to just simulate what your users are doing and then orchestrate it through the orchestrator. Yeah, and for orchestrating all of these tools together, you will need maybe to work with a CI server, such as maybe Jenkins or TeamCity, and also have tools to automate your bits. So all of these options are valid, and there isn't an option better than the other. But again, whenever you are starting, start with what you know, start with tools that you are familiar with, and that they will help you through this journey. And also, I would say, start with small steps. You don't need to have this fully automated cycle. You don't need to have this full automation for all of the phases of your project. You can start, for example, with maybe automating the build and just deploy into testing into the testing environment, and then from testing to to production, you can keep this, for example, as a manual task to be done. So it's your choice how you are starting, but yeah, I would highly recommend that you make baby steps. Okay, yeah, so maybe let's go to a bit of a demo if we don't have questions. Yeah.
I have one question about the build script. Is there a recommendation for where to put your build script? Should you bundle it in the repo itself of your project? Or do you have like one separate repo to put all the build scripts for all your projects?
So
In both scenarios, and both have advantages and disadvantages, because sometimes it's hard that it's versioned with the code, because maybe you want that extra archiving step for older code. You know what I mean? Or
yeah, so ideally you put the build script in under the same repository of your project. So so that Gradle will be able to recognize it, because you are this script, you would be writing a script that relies on different plugins, different tasks, and then these tasks are only recognizable by Gradle. So you will be running specific commands to do this bit, and this building tool is expecting that your script is under the repository of your project.
Also, if you put it not in the same repository, you might have, when you further automate, the problem that it will break when you do a change to your code.
So if you change your code, but your build script is not updated yet, then it might break your automation, right? So you always want to have it at the same commit, so you can change both synchronously. Otherwise, your automation will depend on you changing it somehow synchronously.
yeah, you can have a commit point to that separate repo.
Yeah, but then you have complexity out of hell, so it doesn't make sense.
Yeah, good point. Thank you. Yeah, so let's maybe go to a bit of a demo. Our requirement is to have Gradle installed, and since Gradle is built on Java technology, then you also will need to have Java installed in your machine. Let's start maybe with the setup of a project. So let's maybe convert a normal project to a Gradle project. Here I have a normal Progress Developer Studio project. There is nothing fancy in that project. We will try to first convert this project to a Gradle project and see what will be the created files after this task. So with the release of the DevOps framework, we released what we call ProGradle, which is very similar to the Gradle command, but with some specifics for progress. So whenever you run this command, it will download Gradle for you in your project, and it will download the compatible version of Gradle to your OpenEdge version. So for example, if here I'm working with 12.8, so it will download Gradle 8.2 for me in my repository. It also has some capabilities, like if you write progradle.init, for example, then it will initiate a wizard of converting my normal project into a Gradle project. Let's maybe run it together. Okay, so I need to just close this one. Yeah. Okay, yeah. So as I said again, here I have a very basic project of that has into it different classes. It relies on two databases, and we will be trying to first convert this project, this Progress Developer Studio project into Gradle project, so we can maybe afterwards start writing our build script. Okay, so we will start maybe proenv here. Go to the repository of my project. And then run progradle.init. It will take time, since it will be downloaded all dependencies for the very first time in our project. So here we have the command running. And here we have our project. And yeah, now, from a very first view, we might notice that there were some files added. But here the wizard is asking me a few questions to be answered. So it asks me what type of project is this. The only relevant type for us is basic project, so we will hit basic. It asks me what type of DSL do you want to use writing your build script. I will go with Groovy. Asks me for the default name of the project. I will keep it to default for now. By default, it takes the name of the repository, but you can adjust it if you want to, and you can even adjust it after doing this in its step. So, and here I will keep it to default because the rest is not relevant for us. So here, my project was converted to a Gradle project. And if I go back to my repository, I might see that there were some other files added, such as, for example, the build Gradle file, which will be my Gradle, my build script. Here, where I will be defining the dependency to my packages, the ABL-based package, and also maybe the base package of Gradle, and also define my tasks, such as the running ABL unit testing or compiling, and so on. Also, the settings here, the name of the file where we define it. The name of the project is also set here, so you can also adjust it if you wanted to. But if I open my build script, I will find that it's empty, still don't have anything into it, and I need now to start writing my code to just define what I'm going to do through this build phase. Just to win a bit of time, I have the same the same project here in Developer Studio, and here I added all the needed tasks that I want to have. So I started here with defining the dependency to my plugins. Here I'm relying on the base plugin of Gradle, where I may be finding tasks such as, for example, check or assemble and so on. And here I'm introducing the ABL base plugin, and from this introduction here, or this definition here, I can now call tasks such as ABL compile and so on. So, as I said, this project here is supposed to connect to two different databases. We will have here our database connection part. So here we are defining the database connection part, and databases should be present in the build directory. I have two databases here. I'm connecting to them with -1 option, so to just go with a single user. And then here we have since we are also creating databases through this build project, so we are also relying on the create task project, create database task. So if in every task you will be defining the name of the task, like this one. And here you are calling the type of the task. The type of the task is like interfaces in object-oriented programming language. So you are calling them, this is the predefined task that is coming from the ABL plugin, ABL DevOps framework. And then if you are saying that create sport tasks, you can call it, for example, my create sport DB. And then here you say that it's from that specific type, then it will know that I need to have special properties, I need to have special structure, and I need to perform specific task, which is the task of creating a database. Also, you can create, here I'm creating a database from, a copy from the template database. Here I can also create a database from ST file and DF file. So here the second database will be created from ST file and DF files. One of the also important tasks to know is maybe the compile task. So here we have our compilation task. We can specify in our compilation task the source from where we are taking our code source, type of the code source that we want to compile, and also our repository for our codes and so on. Other thing that, for example, if you are running ABL unit testing, so here I'm running the ABL unit testing. So here I called my task test sport app, and here it's from type ABL unit. So it will know that I am a task for ABL unit testing. I specify the source of the testing classes and also my propath, and it will here perform my unit testing. So all what I defined in my classes to be executed as unit tests will be performed here. And here we can see that I have dependencies. So from the ABL unit task, I cannot run it unless I did the compilation of my code source. I did the creation of the databases, and I also created few cases or few data in my database. So I can have different dependencies in the same task. You can also have specific dependencies define specific dependencies for predefined Gradle tasks that are coming from the base plugin of Gradle. For example, here I have the check task. I said that it depends on, for example, the testing. So if someone runs the default task of checking, then I will be for sure performing my test sport task, which also depends also on all of these tasks. So we can here run it also manually. So we can come to our program and then run Gradle build, and it will also run the script we defined here. So all the script we defined here will be executed once we run Gradle build, or we can also say, for example, Gradle tests. We can also say Gradle test sport app, and it will, in this case, run the specific unit testing task that will trigger all of the other tasks because all of them depends on it. So we have different capabilities, and we can do a lot because we also can populate database scheme. We can create databases, connect to them. So it's way more than what AntScript can offer nowadays. If we talk about real life scenarios, then we are not really willing to only develop this script or have our build script and then that's it. But we will be maybe willing to have an automated pipeline, so CI/CD pipeline. And from the moment our developer submits his code source to GitHub, maybe you want to have this build triggered automatically to just go with the next steps of maybe building, running your unit testing, and then submitting the code source to testing or staging environments. Here I have another project, which is a Progress Developer Studio project. And this Progress Developer Studio project, I configure it to be connected to my Git repository and run from that Git repository a specific, so it's connected to this branch from Git. So I'm specifying the Git repository, specifying the branch, and also I'm specifying that this is a Gradle build. So I'm building using Gradle, and I'm also specifying where it will be finding the wrapper file. So even my Jenkins server doesn't have Gradle installed into it. This will make it work perfectly. And then here I'm specifying what task I want to run. Here I just decided to run my test cases, which is an ABL unit testing that has a dependency on the compilation task. Yeah, I just have this job here. So at the moment I submit my code source, I can trigger automatically a build process. But here I will be starting it manually. So I will just start a build, and at this time, what Jenkins is doing is just going to my Git repository, download the latest changes I have in my Git repository, put them here, and then start a build process. Yeah, in this build process, it will execute my ABL unit testing. I can check here my console. Where is the console? Yeah, one moment. So, yeah. So here I can see that I executed my task, which was my ABL compile, and I executed my task, which was my test cases, and my test cases is dependent on my ABL compile. That's why it was also executed, and I also executed 2 test cases with a successful result. I can go to the my output and see all the files that were resulted from this. So console changes. Where I can find the output. Build now, workspace here. So here I can go to workspace. Yeah, I can see all the output that, so the code source from Git, and also I can see that I have a repository called build where I putted all my, the output of my build script, and I can take this, install it in any other machine, and it will be working fine. And you can also take it to other steps of automation. So you can also have an automated deployment and so on. Yeah, so DevOps is a bit complex journey if we think of it like a full automation. All of it needs to be automated. But if you take baby steps, if you just start with it, it will solve a lot of challenges in your organization. And mainly, it will make us familiar with change, willing to change and not having that stress of hot fixes and normal releases that will cause a lot of issues afterwards. That was it. Thank you.